Hello everyone. In this video we are going to understand the basics of trigonometry. So it's Introduction to Trigonometry, class 10. The word trigonometry is derived from Greek words tri meaning three, gon means sides, and metron means to measure. So trigonometry in fact is the study of relationships between the sides and angles of a triangle. So let us see what do we have in this.
Trigonometry we know is a branch of mathematics which deals with right angle triangle. Here we observe there is a triangle PQR which is right angled at Q. Now, if suppose I mark the angle, this angle as theta, okay, then side PQ would be base. The side which is opposite to the angle is perpendicular and the side opposite to 90-degree angle, this side or also called the longest side, is hypotenuse. Now in trigonometry we have to deal with the relationship of sides, these three sides which are base, perpendicular and hypotenuse. Their relationship would be studied with the angles.
So basically we have these 6 trigonometric functions: sine, cosine, tangent. I would call them their partners. Sine's partner cosecant, cosine's partner secant, and tangent. For tangent it is cotangent. Now why do I call them partners? Because when we would talk about ratio of sides in terms from here, from this triangle, when you pick up ratio of sides, whatever would be the ratio for sine, just reciprocate to obtain cosec. For cos, whatever we have, reciprocated to obtain for secant, and similar thing would be done for the third pair. Let us begin with this now. Observe this triangle very carefully. It's a triangle PQR. Angle is formed at vertex P, so this side PQ is base, or another way is, or what else can we say about this base? It is actually the adjacent side where theta is formed, side adjacent to theta. Now the side which is opposite to theta is called perpendicular, and it is mentioned here this is opposite side, and this side, the longest side, would always remain hypotenuse. When we write t ratio for the first function, we would not be writing it completely sine, we would just write sine theta. Sine theta would be perpendicular by hypot, perpendicular, which is, I'll just write it in that form first of all. It's P by H. Sine theta is, what is perpendicular here? It's QR. Hypot is PR. Okay. Sine is done. Reciprocate it to obtain for cosecant. Cosecant theta would be PR by QR. Straight away reciprocate. Since, why do we reciprocate? Because sine theta and cosecant theta are reciprocals of each other. Remember this rule. Then comes cosine or cos theta. Cos theta would always be base upon hypot. Base, the value, the base over here is PQ, hypot is PR. Now cosine's reciprocal or partner is secant, so secant theta would be PR by PQ. The reason? Because cos theta and secant theta are reciprocals of each other. These are important results. Sine cosecant reciprocals of each other. Cos and sec are reciprocals. Then moving on to the next function in terms of ratio of sides, tangent theta or tan theta would be perpendicular upon base. Perpendicular. So tan theta becomes, what is perpendicular here? It's QR. Okay, QR upon base, which is PQ. For cotangent, cotangent short form we would be using, we would not be writing it cotangent all the time. It's cot theta. Cot is reciprocal of tan. So it becomes PQ by QR. The reason? Because tan and cot are reciprocals. Tan theta is 1 by cot theta. Now, dear kids, remembering all these ratios in terms of ratio of sides, remembering all these functions, at times it becomes little tedious, difficult. So we have a memory trick for this, which I'll share with you. There are two ways. First one is when you talk about perpendicular, when you take it in terms of perpendicular and base. Let me just write it here only. We say Pandit, Badri, Prashad, हर बोले सोना चांदी तोले. Look at this. S sine. Sine is P by H. Do we have P by H? Yeah. Sine theta is perpendicular by hypot. Cos. Cos theta would be base by hypot. And tan theta would be perpendicular by base. Okay, this is a memory trick which can help you to memorize this formula, this ratio, set of ratios easily. And once you are done with sine, cos, tan, for the another set you just reciprocate them. Remember this also, sine, cosecant are reciprocals, cos, secant are reciprocals, and so is the case with tan and cot. Now another is, one more trick is there. If you take the sides in terms of adjacent side and opposite side, that trick is, we say so ka to a. So ka to a. Now this means sine would be opposite by hypot. Cos would be adjacent by hypot. What opposite? Opposite side by hypotenuse. Cos is adjacent side by hypotenuse. Tan would be opposite side by adjacent side. So this is another way. Whichever method, whichever way you find convenient, go for that. It is one and the same thing, and I'm sure whole process, whole steps, complete working must be clear to everyone. Let us discuss question number 1 from exercise 8.1. We are given a right angle triangle ABC in which AB is 24 centimeters, BC is 7 centimeters, and we are asked to find the value for sine A and cos A. Whether it is sine or cos, we need the third side. We should know the measurement, the value for AC. So let's quickly calculate AC. We would apply Pythagoras. So AC square we know is AB square plus BC square. This is application of Pythagoras theorem. Right, so AC square would become 24 square plus 7 square, which is 576 plus 49, which makes it 625, and hence AC is 25 centimeters. So hypotenuse is calculated as 25 centimeter. Now look at this very carefully. If it is sine A, as we all know, sine theta is always, what is the value for sine theta? Sine theta is perpendicular by hypot. So if it is sine A, angle is formed at vertex A. So what would be, which side would serve as perpendicular? BC would become perpendicular. It's BC upon hypot, which is AC. So the value for this would be 7 by 25. Sin A is found. Then comes cos A. Cos A would be base by base. Base for this. When angle is formed here, AB is base and AC is hypot. So this would be 24 by 25. Centimeters you can cancel, and ultimately, since it's a ratio, it has to be unitless. Then let us talk about sin C cos C. Sin C, angle has now shifted here. If angle is here, which side is perpendicular? AB is perpendicular. AB. Hypot remains AC. So this is 24 by 25. Same way cos C. Cos C will be, now when I say cos C, angle is here, base is BC. Hypot has to remain same. So this is 7 by 25. So that's how your first question would be done. I'm sure this must be clear. And see, you would observe one more thing. Sin A is equal to cos C. Observe this result, because this would help you to understand one thing which makes them complement angles. Sine and cos are complement of each other. We have this concept for exercise 8.3. Although that is ruled out this year, CBSE has removed it from the course. But this result, sine cos are complement, tan and cot are complement, and secant cosecant are complement of each other. That would help you to make that trigonometric table, which would be for the next exercise, exercise 8.2. Now let us discuss question number 6, which says A and B are acute angles such that cos A is equal to cos B. We need to show that angle A and angle B are equal. See, as you can see, question simply says they are acute angles. Choice is yours. You can make the angles in the same triangle the way it's done here. Triangle ABC is made. Angle C is 90. C has to be 90 because A and B are acute angles. If this is 90, these two has to add up to 90. Definitely A and B would become acute angles only. Condition says cos A and cos B are equal. Show that angle A and angle B would also be equal. For this, let us just write the ratio of sides. When it is cos A, we know cos A in terms of ratio of sides from here. How would you write it? Cos A indicates angle is here, this is base, and cos theta is always base by hypot. So cos A, base is AC, hypot is AB. Then let's write the value for cos B. Cos B would be, base has now become BC because angle has shifted here. This would be BC upon AB. What are we given? The given condition says that cos A is equal to cos B. Put the values. That implies AC by AB must be equal to BC by AB. Look at their denominator. It is same. That indicates AC and BC are equal. Now if these sides are equal, it's proof that these sides are equal. The angles must be equal. Angle opposite to AC, angle B, angle A. So if B and A are equal, our result is proved.